So our vocabulary for today, an exponential function is a function in the general form a b to the x power, where a and b are being multiplied together. So there are two options here. We have exponential growth and we have exponential decay. So for exponential growth here on the left-hand side, so here's our exponential growth. Exponential growth occurs when the b value is greater than 1. So for example, we could have y equals 2 times 3 to the x power. Since the b value here is 3, that's what makes it an exponential growth problem. On the right-hand side, we have exponential decay. In this case, I know it's exponential decay anytime the growth factor is less than 1. So we could have y equals 2 and then 1/2 in here to the x power. Again, the b value for this problem is 1/2, which is less than 1. So the next slide, we're going to look at the b values to determine growth or decay. So on the question on the left-hand side, here is my b value. I need to decide if that's greater than 1 or less than 1. So b is 1.5. Since b is 1.5, I know that that's greater than 1. So it's growth. That means the graph should look like this. So in order to get to the point of graphing these, we're going to plug in x values and just make a chart. The majority of the time, we just start at -2 and we work all the way up to +2. In order to do this, we just need to get our calculators out. If you have a scientific calculator, you can do this all in one step, just typing it all into your calculator. So you're going to do 2 parentheses 1.5, and then we need an exponent of 2, or -2, excuse me. So we would plug that -2 in for x. When you type this in your calculator, if you have a scientific calculator, it's going to be 2 parentheses 1.5, close your parentheses. Then you're going to use the caret key, which looks like an upside down V. And then your -2 equals. So take a minute and type that into your calculator. If you need to go grab one, go grab a calculator. They're really essential today. And you don't want to practice using your phone's calculator, if at all possible, because your cell phone's not going to be allowed to be used during the final exam. So you want to get into the practice of actually using a handheld calculator, because you can use that calculator on the final exam. And remember, your final exam has to be taken in person. So somebody's going to check to make sure you're not on your phone, all that stuff. All right, so when I typed that in my calculator, I got 0.89. We are going to graph these, so our numbers don't have to be exact, they just have to be close. So if you want to round to 1 decimal place, that's fine. I always told my students to leave at least 2 decimals in case the numbers are really close to each other. So with that being said, that's going to give us the ordered pair, -2 and 0.89. So we could graph -2, comma 0.89. We would just go left 2 and then up a little bit underneath 1. So then if you have a scientific calculator and you type this all in there previously, you can just edit. So some of the calculators, you hit the left arrow and you can get to that -2 that we want to change to a -1. Other calculators, you have to hit the up arrow and then the enter to bring that equation down to the next line so you can edit it. Or if you want to type it all in again, that's fine as well.
Andrea, I have the calculator and I try making the breaking this stuff and I put in the negative, the 2 exponent and give me.
Hold on, I can't hear you. Give me just a second.
You listen now?
All right, can you say it again?
This calculator that I have or I use, I put in the exponent -2 and make me mistake. So not give me any answer.
What calculator do you have?
I have Texas Industrial TI minus 30x 2x.
And what's it telling you?
It's mistakes. I put in 2 parentheses, 1.5 parentheses, -2 exponent and make mistake. Say is wrong.
So it's giving you an answer of -3?
No, it's not giving me nothing. Say is wrong. Something is wrong. I don't know what is wrong.
And you just type this in?
Yeah. Say synthesis is wrong. Synthesis is wrong.
I'm trying to think what could be wrong. Can you try to reset your calculator?
Okay.
Yeah.
I'll make it the same stuff. Okay, you continue. I can figure out later. Sorry.
I'm not sure what could be wrong with it to call that.
Me neither. So I figured out later. Sorry.
You're fine. So now when you type in that -1, you should get 1.3 repeating, which is the order pair -1, comma 1.3. And then we're just going to work our way down the entire list using our calculator to find those answers. So take a minute and fill out the rest of the table. So hopefully you ended up with the ordered pairs 0, 2, 1, 3, 2, 4.5. So we're going to practice another one over here on the right-hand side. So first thing I want you to do, think about whether this is growth or decay. So when you look at growth or decay, you need to decide what the B value is. The B value is always the number that has the exponent attached to it. So in this case, it's 1/2 or 0.5. So our B value is 0.5. That is less than 1. So this is a decay problem. So in this case, we just start out with larger numbers at the beginning, and our numbers should decay or go down as we go down our X value list. So again, I'm going to use X values, -2, -1, 0, 1, and 2. Then I'm going to take 2 times 0.5 to the -2nd power. So in my calculator, I'm going to do 2 parentheses 0.5, close your parenthesis, then your caret key to make an exponent, -2 equals. You should get a value of 8. So that would give you the ordered pair, -2, 8. Then you're going to repeat that process all the way down the entire table. So you're going to take 2 times 0.5 to the -1st power. So all of these. So take a moment and find all 4 of these Y values and then go ahead and write your ordered pairs. All right, so hopefully you got values 4, 2, 1, and 0.5 or 0.5, either way works. And then your ordered pairs will follow -1, 4, 0, 2, 1, 1, and 2, 1/2. So that's how we find all of the X and Y coordinates before we graph them. So looking at the structure in exponential models, so here we're asked without graphing, determine whether the function y equals 14 times 0.95x represents exponential growth or exponential decay. So remember, in order to classify this as exponential growth or exponential decay, we're looking at the number in which the exponent is associated. So the exponent is attached to the 0.95. So we need to decide whether 0.95 is greater than 1 or less than 1. So our B value is 0.95. Since that value is less than 1, this would be a decay scenario. So we didn't have to graph it. We can already know that it's going to start high and then the numbers are going to narrow down and get smaller. So your graph would look like this here on the right-hand side. So down below, we have 3 equations. I want you to go through each equation, determine what the B value is, so the growth or decay factor. Look at that and then classify it as growth or decay. All right, so for letter A here on the left, we have a B value of 0.12. That is less than 1, so this is a decay problem. Question letter B, we have a B value in this case of 5. Since that is greater than 1, this is a growth scenario. And the last one over here on the right-hand side, we have a B value of 1/2. 1/2 is less than 1, so this is a decay problem. So noticing whether these are growth or decay problems gives you the general shape of your final graph. So the question that is on the final that relates to this is going to be multiple choice. So you'll see all of your assignment today is multiple choice, picking the correct graph based off of an equation. There are a couple different things that you should know. If you have a decay problem, your graph is going to start off large and get smaller like this. So both of these graphs should have this general shape. A growth graph should look like this, starts off small and gets really big as it heads to the right. So automatically, if I have a problem that has a b value less than 1 and my graph is exponential growth, I know that that would be a correct answer. So here we're going to start graphing. We're going to graph 4 times 1/2 to the x power. And like we did on the last problem, we're just going to start out making a table of values. I'm going to be lazy and just make an XY chart. I'm not going to write down exactly what I'm typing into my calculator every single time, because I'm going to just type it in one time and then I'm going to edit and then just hit enter again for all the other values. So I'm going to stick with the -2, -1, 0, 1, and 2. The majority of the time doing those 5 numbers will get you a good answer. So then in my calculator, I'm going to take 4 times parenthesis 1 divided by 2, close your parenthesis, then your caret key, -2, and equals. So for this one, you should be getting an x value of 16. So no need to be alarmed here. This should, since our b value here is 1/2, I should start out with high numbers and then I should level out as I go to the right. So then I'm going to edit what I have written in or typed into my calculator. I'm going to change the -2 to a -1, and I'm going to get 8. I'm going to change the -1 to a 0. I'll delete the negative and change the 1 to a 0. That's going to give me 4. Going to change the 0 to a 1, and I'm going to get 2. I'm going to change the 1 to a 2, and I'm going to get 1. So that gives me a list of all of my x values that I'm going to graph. So I'm going to start at -2, 16. So go to the origin, go left 2, and then up 16. And I'm going to have a point right there. Then I'm going to graph -1, 8. So I'm going to go left 1 and then up 8. It's going to give me that point there. Then I'm going to graph the ordered pairs 0, 4. I'm going to start at the origin. I'm going to go up 4. Then I'm going to go to 1, 2, 2, 1. And then I'm going to play a little game of connect the dots. So all of these graphs are going to kind of level out here. So when I draw this, I want to draw that right-hand side leveling out. I don't want to draw it crossing the x-axis unless the graph's been moved up or down. In this case, it has not. We'll talk about that in a little bit. So there's my final graph. Again, if I was doing the question on either the assignment or the final exam, I'm going to look for these 5 points and see which graph is exponential decay. It's declining from left to right as you look across it. And it has these 5 points. Again, we could do more points. If I wanted to do 1, I would get 1/2, 1/4. You'll see my graph doesn't kind of swoop down enough, but you get the point. So here's another exponential graph that we're going to graph. So again, we're going to start off by making an XY table. And we're going to type those into our calculator. So we're going to take 2, caret key, and then -1. Make sure that -1 is not being included. So you might, depending on your calculator, you might have to type 2 caret key -2 closure parenthesis and then -1. So depending on the calculator you have, this way's going to work regardless of what calculator you have. So take a moment and see if you can fill out your chart. If you're feeling ambitious, go ahead and graph for us. right, so we should have ended up with -2, comma, -0.75. So that's gonna be right down here-ish.
Okay, I got it number 4. I make it
-1, comma, -0.5, so up just a little bit higher. Then 0, 0, it's gonna go through the origin. 1, 1, 2, 3. If you wanted to keep going to get a more accurate graph, you could. You would get like 3, 7 would be the next point. 4, 15. Again, you could keep plugging in X values if you wanted. You could do the same way with -3, -4, -5. I always just pick these 5 because they give me in general, they give me a good graph and I'm always consistent. So then we're going to connect them. Remember, in this side, the left-hand side is going to flatten out and the right-hand side is going to increase because it's exponential growth. So here's my graph. We're always aiming to connect those to make a smooth curve like this. Going down to a little bit more complicated problem here, we have 2 times 3 to the x minus 1 power plus 1. It's very important that when you type this one in your calculator that you're going to use parentheses around the x minus 1 so that it all gets put up into the position of the exponent. So again, starting off with an XY table. So in my calculator, I'm going to type 2 times 3 caret key, another set of parentheses, -2 minus 1. So here I have double parentheses plus 1. And again, your calculator might be slightly different. If you need help typing these in your calculator, you can send me a picture of your calculator. That would always help so I can see what buttons you have to compare to mine. And then I can shoot you back a text to let you know what you should type in if you give me a problem that you want typed in. So for this one, I'm getting 3.0. I could keep going 3.037. But again, we're just graphing these. They're not going to be really exact. So if I put 3.037, I'm going to graph that pretty stinking close to 3. Then I'm going to plug in -1, then I'm going to plug in 0, 1, 2. When I did mine, I went ahead and plugged in 3 as well, just to give myself a more accurate answer. So take a moment and fill out the rest of your table. So when you get your table filled out and your graph finished, go ahead and check it with mine. Here we have an exponential growth graph. It's going to level out right there at 3. Sometimes you'll see people draw in a horizontal asymptote like we learned about a few weeks ago or last week. Just know that your exponential graphs are always going to essentially like level off on one side and kind of flatten out. It's going to approach that line. So I could plug in -5, -6, -7. All those numbers are going to be really close to 3. They're going to get closer, but they'll never actually cross 3. And then the last one here is definitely the most complicated. We've got all sorts of things hanging out front. We've got a fraction, we've got a +1 with our exponent, and we have a +2 out at the end of the equation. So again, we're going to make a table of values. And then we're just going to put all of this in our calculator. Again, it kind of gets confusing because we need to put parentheses around this. I might change this 1/2 to 0.5 just to save myself a set of parentheses there. So I would type in 5 times 0.5 caret key -2 + 1 in parentheses, because all of that belongs in the exponent. And then I'm going to close my other set of parentheses +2. I've also seen people use one less set of parentheses, but they put the 2 out front. So sometimes I've seen that. It gets a little bit tricky if it's a minus sign. You got to put a -2 out front plus all of the information. So stick to this for now. If it doesn't work, reach out to me and we'll talk about how we can type things in our calculator differently. So when I type in -2, all that information to get the -2, I end up with an answer of 12. So the ordered pair, -2, 12. So if you got -2, 12, go ahead and type all of the other numbers in for your X values to get your final answer. right, in order to graph this, I'm gonna start at -212. So I'm gonna start at the origin, go left 2, up 12. It's gonna give you that point right there. -1, 7, 0, 4.5. 1, 3.25. 2, 2.625. If you wanted, you could, again, keep plugging in numbers to get a more accurate graph. So if you plugged in 3, it would be 2.3. So it's just going to keep getting closer and closer to 2 in this case. Just like that.